Hello class, welcome to this video on the 2.7 practice. So we're going to cover the practice questions from Canvas. So let's go ahead and get started. This practice is about coefficient of determination, assessing regression models. We also discuss standard deviation of residuals, and we talk about residual plots. So the first few questions are conceptual questions, true or false. So the coefficient of determination, that's r squared, is a value that measures the percent of the spread in the y values. Spread is the same thing as variability or variation. This is kind of like a definition question. So the coefficient determination r squared is a value that measures the percent of the spread or the variation in the y values that are taken into account by the least squares regression line. And it helps determine how well the regression line makes predictions. This is true. This tells you how well the regression line makes predictions, because if that's a large value, that indicates that most of the y values, the spread in the y values, is taken into account by the regression line, which means that the regression line is accounting for all of the y values in the model, right? So the model is pretty good if it takes into account most of the y values. All right, question 2, the coefficient of determination, r squared, indicates how much of a reduction there is in the sum of squared residuals when one switches from the least squares regression line to the mean of the y values. Okay, so there's a slight difference here from the definition, okay? Remember that the r squared is the difference when one switches from y bar to y hat, not from y hat to y bar. Because remember, if r squared is large, that means that there is a large reduction. This usually has a large error. This usually has a small error. And so if it's a good model, then you're going from a large error to a small error, which means there's a large reduction, because there's a large reduction. And because there's a large reduction, that means that r squared is large in general. Okay, so this indicates how much of a reduction there is when one switches from the mean to the regression line. So these should be swapped, okay? So this is false. All right, question 3, a relatively large standard deviation of residuals value, that's S, indicates that the least squares regression line is making good predictions. And so, okay, so they're saying that S is large. So let's look at the formula for S. Remember that S is the square root of the sum of the squared residuals y hat divided by n minus 2. So if S is large, then that means that this is large. And if that's large, that means that the error is large, right? Because residual means error. And if the error is large, well, then that means that we don't have a good model here, right? If our model has so many errors in it, or has large errors, well, then it's not a good model. And so if S is large, that means our regression model it's very poor at making predictions. Okay, so relatively large standard deviation of residuals value indicates that the least squares regression line is making bad predictions, not good predictions, or poor predictions. So this is false. All right, question 4. The standard deviation of residuals, S, indicates on average how small or large your residuals are. So that's S indicates on average how small or large your errors are. And that is true, right? So this right here is your error, and you're adding the errors, right? When you add the errors and you divide by however many you have, minus 2, of course, then this is an average. This right here is a type of average. So it's saying on average, how large are your errors? Or how large are your residuals? Residuals are like your errors. So this is true. Question 5. What are some ways to assess a regression model? Select all that apply. So basically the point of the lesson. How are some ways that we can assess a model? Well, we can look at so can we look at the standard deviation of the explanatory variable? Meaning Sx. Can we look at that? Well, in general, Sx is not going to tell you much about the regression model. It's going to help you calculate the equation of the least squares regression line, but it's not going to really help you to assess the model. So this is not true. Look at the standard deviation of residuals. This is S. Yes, that is correct. Remember that if the S is large, the model is not very good, and so you're assessing the model. All right, so look at the equation of the regression line. Well, the equation of the regression line in and of itself does not really tell you much. It just tells you the equation. So this is not going to be useful, okay? It's just going to tell you the equation of the line. It's not going to tell you whether it's good or not. Look to see if there's any pattern or lack of pattern in the residuals. Yes, this is correct. So remember, when you're looking for the residuals, you generally draw a residual plot. If there is a lack of pattern in the residuals, then that indicates that it's a good model. And so look to see if there's any pattern or lack of patterns. Look at the residual or the standard deviation of the response variable. So this is SY. No, that doesn't really tell you much, in the same way that this doesn't really tell you much. So no. Look at the coefficient of determination. Yes, this is your R squared value. So your R squared value tells you how much of a percent reduction there is in switching from Y bar to Y hat, and therefore it tells you how good your model is if it's reduced a lot. All right, question 6. Which of the following is true regarding a residual plot that indicates a regression model is appropriate? So the residuals look randomly scattered between negative and positive numbers. There seems to be a cyclical pattern in the residuals. Residuals look like they form a straight line. Residuals look like they form a curve. So remember, if you have a residual plot, if they're randomly scattered, then that indicates that it's a good model. If there is some kind of pattern, which in this case, if there is a cyclical pattern, this is a cyclical pattern where it kind of goes up and down, that's a pattern. That indicates a pattern, which means that that's not an appropriate model. If the dots form a straight line or close to a straight line, well, that's a pattern, and so that's not correct. That would be an inappropriate model. And then similarly, if there is some kind of curve pattern, that indicates an inappropriate model as well. And so the answer is A. The residuals need to look randomly scattered in order for this to be an appropriate regression model. All right, so now we're looking at the calculation of the standard deviation of residuals, S. So we want to calculate S for the data. Round everything to 2 decimal places unless otherwise specified. So remember, to calculate S, we need to take the square root of the sum of the squared residuals for Y hat, then divided by n minus 2. So we need to basically calculate these numbers. So in order to calculate the sum of squares of residuals, we need to figure out the residuals first, right? Which are these guys. So these are the residuals. This is your R. These are your squared residuals, your SR. This is your squared residual for Y hat. And then to get the sum, we need to figure out the total of this column, and that will give us this guy, okay? So let's go ahead and find Y hat. To find Y hat, you need to plug in X into your Y hat model, your regression line model. So then if we do that, we get negative 3.25 plus 6.04 times the X value of 5. Right, so we get negative 3.25 plus 6.04 times 5. And let's go ahead and do this. Okay, so we get 26.95. And they want us to round to 2 decimals. Okay, so 26.95 is my number. All right, so that's my regression, or that's my prediction, my predicted Y value. And so now we need to find the residual. And so to do that, you subtract your Y minus Y hat. So you do this minus this to get this guy, okay? And so on. So we got to do 2 minus negative 3.25. So we'll do it 2 minus negative 3.25. A double negative is a positive, so this is really 5.25. All right, and then next we're going to square that number. So we're going to do 5, we're going to square this number to get this. So 5.25 squared, and then we'll get that number. Get 27.56 because we're going to round it to 2 decimals. All right, so now we got all the numbers here. Now we're going to total this column to get SSR. So we're going to add those numbers now. Do it on here on this calculator. We do that, we get 90.82. So this right here is 90.82. And so that's this total right here. And so now remember, we're going to calculate S now. So we're going to plug in what we just found here, 90.82 divided by n minus 2. So n is how many numbers you have. So here I have 7 numbers. So n is 7. So it's going to be 90.82 over 7 minus 2, which means it's going to be square root of 90.82 divided by 5. So we'll go ahead and calculate that. Square root 90.82 divided by 5. So we get about 4.26. So that's going to be my S, about 4.26. Right, that's how you calculate the standard deviation of residuals. And that's a relatively small number. So that means that the errors are on average are not very large. So that's pretty good. All right, question 8. Calculate the standard deviation of residuals. This says standard deviation residuals. It should not say that. It should say the R squared. It should say the coefficient of determination. So that's a typo there. Not the standard deviation of residuals. All right, so now first off, we're going to need to figure out the Y bar. So the Y bar is the average. So you're going to add up all of the numbers for all of the values for Y, and then divide by however many numbers you have. So based off of this, n is equal to 7. N is how many numbers you have. So you got 7 x values, 7 y values. So n is 7. So we have, so to get the y bar, we need to add the y values. Then divide by 7. So go ahead and get that number real quick. If you wanted to do all this at once, remember you're going to have to put this in parentheses when you do this on the calculator and divide by 7. So we got 7.57. Okay, so we got that here. All right, so that's how you get that calculation. So now we're going to go ahead and get y hat. To get y hat here, you're going to substitute x equals 5 into the y hat model, the regression model. So when we do that, we get 2.43 plus 1.71 times 5. And then we'll go ahead and get that number. We get 10.98. So we got our value here. All right. So now that we got all the y hats, we need to find the residuals. Okay, so we're going to subtract y minus y hat. So this minus that. 2 minus 2.43 is negative 0.43. All right, so that takes care of that. Now we're going to square those values to get this guy. All right, so we're going to square negative 0.43, get that number. Make sure you put that in parentheses. So round it to 2 decimals, so 0.18. All right, so now we're going to do y minus y bar. So now that we know y bar is 7.57, we're going to subtract the y value for that minus 7.57, which is negative 5.57. So that goes down here. Next, we're going to square that number to get the right column. Go ahead and type it in here. I'm going to type it in all at once. So we get 31.02. All right, and so that's how we get all the values from the table. And then you rinse and repeat, and that's how we got these other values. So now what you're going to do is you're going to figure out the sum of these squared residuals for y hat. So remember that this right here is your SR, your squared residual. And so to find your SSR, your sum of your squared residuals, you have to total this column, okay? So you have to add these numbers here. Okay, so let's go ahead and add those numbers. So you get 63.44. So that means that's this guy, 63.44. That's the total there. And now we got to find the SSR for y bar. So this is right here. This is your residual for y bar. This is your squared residual for y bar. And so to find your SSR, you're going to have to total this to get SSR for y bar. So we'll add those numbers together. Okay, we get 101.68. And that's in 2 decimal places, so we're good. And now we're going to get r squared. So remember, to get r squared, you're going to do SSR for, so you're going to do your SSR for y bar minus your SSR for y hat, divide that by your SSR for y bar. And so now we got those numbers, we can actually plug it in. So we got 101.68 minus 63.44 over 101.68. Go ahead and get that number. Remember when you do this calculation, put this numerator in parentheses. Anytime you have a couple of things going on in a numerator or denominator, you want to make sure to put that in parentheses just to be on the safe side. We get 0.37, so about 0.376. They want us to do it to 3 decimals, I believe. Yeah, round this to 3 decimals. So 0.376. So that's a really low number. That means that the error did not change very much. The error did not change very much. It only changed by 37.6%. So the least squares regression line only accounts for about 38% of the variability in the y values, which means that there's a lot of other factors that are involved in determining why the y values change the way they are. And so there's probably a better model out there that accounts for the change in the values than this one. So this is probably not going to be a good model that we have here based off of the number that we have. All right, guys, that is it for the set of problems. I hope you found this useful. And as usual, I'll see you in the next one.